Okay, so I want to do a video for section 1.2 for those of you that were unable to attend class remotely. So we had talked about section 1.2 in class, and one of the key types of problems you want to be able to do is one like number 31 here, okay? Now, on this problem, this is an expression that has variables in it. So that expression is not equal to one particular thing. It depends on what the values of the variables are allowed to be. So part of the directions is to evaluate, which means to find the value of that expression that you see on 31, and they give you that x is 3 and that y is 2, okay? So we're going to wind up plugging those in to those variables in the appropriate spots, okay? So what you would do is you would have a spot sitting there, and in place of the variables, you're going to be putting 3 for the x's and 2 for the y's. Okay. All right, and then once you've done that, the problem is now back to a problem from section 1.1, where all you have to do is watch your order of operations. So it becomes 6 plus 8. Need my pen. Okay, 6 plus 8 minus the 6, all of that. See if I can get that to work better. Over 10 plus 2. Okay, and then the 6 plus 8 is 14 minus 6. So on top we have 8. On the bottom we have 12. And then we reduce that. We notice that 4 would go into both of those. And so your final answer would have been 2/3. Okay, so the first half, or about the first 9 or 10 problems, deal with the questions like that. Okay, all right, then you see here we've got problems where we're trying to determine if a number is a solution to the equation. Okay, so for instance, on number 55, we're trying to find out if 3 is a solution, which means does 3 work when you plug it in for the y so that the left side would also equal 14 like it's supposed to. All right, so what you're going to do there is you're going to put 3 everywhere there is a y. Okay, so right here and here would be a 3, and you're going to ask yourself, do you get 14 when you're finished? And when you do that, that's pretty much the last step on problems where when you learn to solve equations, that'll be the last step you can do, which is basically to check whether or not your solution was correct. So we could go ahead and do the product there and get 6. We could go ahead and work out the 3 minus 2, which would be 1. And then the 6 plus 3 equals 9. Not the 14. So that means no, 3 is not a solution. Okay. And then on the other one, the one to the right of it, we would put 4 where the r is and square it. Okay. All right, we'd have to check that. And so the 4 would go where the r is, and then we'd work all that out, and we'd see if we wound up getting something that equaled 46. So this would be 16. You'd multiply by 3 and get a 48. Take away the 2 would get a 46, which is 46. That does check. Your answer to this one is yes, 4 is a solution of that equation. Okay? All right. Now, the second part of the homework that you'll do is the part that people are asking me the most questions about. Here's where we're translating from the English to the math, okay? And the first 39 through 51 here, these right here, those are just going to be expressions. Okay, like a phrase in an English class. These are just expressions. Okay. Right? These last two are equations. They're going to be a problem that has an equal sign in them. Okay? All right, so what you're going to do, what I want you to do is this. Don't just start at the right and try to replace each word with something. Do a quick read of the whole thing, 12 times a number. Notice where the variable is going to go and pay attention to what letter they want you to use for the variable. Most of the time, they'll want you to use an X, but they might want you to use an N, okay? So let's say we're going to use an X for the variable. So 12 times a number, okay? X is the number. Okay. Now, 12 times that. Times means multiplication. So you might have done this, or you might have done that, and that would have been okay. But probably the best way is in algebra is just when you write it right next to the variable like that, that means multiplication, and that's probably the nicest way. Okay. All right, now let's look at 9 added to a number. So we've got our number X, and then I want you to watch this language, added to and subtracted from. 9 has to be added to that, so that the number has to be there, and then you add 9 to it. That's what you really should be thinking. My math lab's going to give you credit if you do 9 plus X, but that's not really what the words say. But they give you credit because with addition, it really doesn't matter which way you add. Okay? All right, but think about what the words are really saying, because you can get into trouble on subtraction. See how the next two have that subtracted from language? So on this one, you have to be much more careful. This said to do 4 subtracted from a number. All right, so the number would be X, and then we're supposed to subtract 4 from that, which means the number had to already be there, and you're taking away 4 from that. Has to be after it like that. That would be the answer to number 43. This right here, flipping them around, that does not have the same meaning, and that would have been marked wrong. So see how it doesn't pay to just start translating word for word. Do a quick read. A number subtracted from 7. So that's where my X is going to go. That is my X, I mean. And then it says a number subtracted from 7. So I'd have to have the 7 and take the X away from it. Okay. Number 47 is also subtraction. The word difference means subtraction. Okay. The word sum goes is an equivalent type word. That's addition. Product means multiplication. And if they had used an example like a quotient, that would have been division. Okay. So on 47, it is going to be subtraction. And when you do the difference of a number and 8, or if you did the sum or the product or the quotient, the number would be first, the X would be first, and then this is different, so it should be minus. Then minus 8. If it had been the sum of a number and 8, it would have been X plus 8. If it had been the product of a number and 8, it would be X times 8. And then if it had been the quotient of a number and 8, you would have had the X on top and the 8 on the bottom. So it does go in the order in which the words occur when you're reading them. All right, now 49 has divided by. So that's division. And with division, you could have done this. 18 divided by X like that. You could have written it with an 18 over X. Even that little sideways slash bar. Okay, that also means division. All right, and if you were doing old-fashioned division symbol, the X would have gone into the 18 that way. Okay. So 18 divided by X, 18's in front or on top. Or in the old-fashioned thing, it would be what's underneath the division symbol. All right, now what's a little different about 51 is you have two operation words. So you have the word product, and then you have this less than language. So you're going to have multiplication and subtraction. But again, don't start at the left and move to the right. Just do a quick read, just scan it. Notice the product and the less than, have that in your mind. But then really start here with letting x be the number. All right, then you kind of back up from there, and you're going to do 4 less than that number. So here's my number. I need 4 less than that, so I got to take away 4 from it. So it'll be after it like that. Okay. Then we're going to back it up, and it wants the product of 6 and all of that. And you have to watch that. So if you wrote a 6 like that, that would be the product of 6 and x. But you need the product of 6 and all of this. So we're going to use parentheses around it like that. And just write the 6 right next to it, and that indicates multiplication. So this would be the product of 6 and x minus 4. This would be incorrect because that would be the difference of 6 times a number and 4. The difference between 6 times a number and 4. It's not the same. Okay. All right, now when you get to 65 and 71, you wind up having problems that are sentences. Notice they end in a period. You have a verb. The verb is where the equal sign comes from. Sometimes they'll just use the word is. Sometimes they'll use the word is equal to. Okay. So the first thing you do is a quick read of it. The sum of a number and 8 is 18. You're not really trying to hang on to any of it. You're just trying to see that is would be your equal sign. Okay. Then that separates the problem into 2 phrases. So you do what's after the equal sign, which would just be 18, and then you work on this part that's in front here. Okay, so this one said the sum of a number and 8. So if we let x be our number, sum indicates addition. So you would do x plus 8. So when you do these on my math lab, it's going to have a little place for you to put that in like that. And then it'll have a box on the other side as well. All right, then what it goes on and does is it has like a little set, and it puts several numbers in there. So it might put something like, 5, 10, 15. And it asks you which of the numbers in that set are solutions of that equation. So the idea there would be that you'd plug in a 5, see if it works. But 5 plus 8 is 13, not 18, so that does not work. Okay, then you go back and you try 10. 10 plus 8, oh, that does turn out to be 18, so 10 works. If you put in 15, 15 plus 8, that's 23. That does not work. All right, when you know a little bit more, you would know that this only can have one solution, so I just wanted to mention it to you. This is an equation that's got an x to the first power. It means it's a linear equation. It's going to have only one solution. You can later have equations like this one right here, where when you solve it, it turns out to have 2 solutions. And that has to do with the degree of that being a squared, the fact that this is a quadratic equation. Okay. All right, now let's try another one of these. So again, in my math lab, you're going to have to fill in the boxes without doing any simplifying. Then they'll give you this set, and you just test the numbers they give you to see which ones work. Okay. All right, let's look at this next problem. 3 times the number is equal to 8 more than twice the number. Whole lot going on. Just did a quick read. I wasn't really trying to remember any of it. I just noticed it was a sentence. I'm going to put an equal sign where the is equal to is. Then I'm going to take each side independently. I'm not even paying attention to the other side. Just take one of them at a time and figure out what it would be using math symbols. So 3 times a number. the number is x, 3 times that would be 3x. Okay. All right, on the other side, I need 8 more than twice the number. Now the word twice should be something that you're not super familiar with. Twice actually means 2 times. Let's see if I can get that to write better. Twice does not mean to square it. It means 2 times the number. Okay, so if the number is x, twice the number would be 2 times that, and then you need to do 8 more than that. So it'd be best to write it with plus 8 after the fact. Okay, and then just like before, they're going to give you some numbers to try, like 4, 6, 8, and 10. And you're just trying to see which of them would work. And so you go and you plug in 4 for the x on both sides, and you look to see if the two sides give you the same value. That's what equals means. So this would be 12, but over here that would be 8 plus 8, which is 16. Sorry, so 4 doesn't work. Okay, if you tried 6 on both sides, that would be 18. And that would be 12 plus 8. Well, that would be 20 then. So that doesn't work. Okay. Well, let me move on. Let me try 8. If I put an 8 in here, I get 24. If I put an 8 in here, that's getting multiplied by 2, which would be 16. But when I add the 8, I get the 24 I'm supposed to. So 8 works. And again, this turns out to be a linear equation. You don't necessarily know that yet. So it turns out 8 would be the only solution. There can only be one. Okay, but you wouldn't necessarily know that. So you might come in and try the 10. But if you did, you'd get a 30 on the left. And on the right, you'd get 20 plus 8, which is 28. So it would not work. Okay. All right, so that's the section 1.2 work. Okay. All right, I'm going to go into my math lab and look at just 2 questions people have asked me several times, several different people have asked me about, and just share that with you. So I'm going to go into the 1.2 homework. Won't take me but a minute more. I thought I already had this pulled up. And let me just go into one of them. Go into the assignments. Okay. And let me go into the 1.2 homework. And one of the questions people asked me about quite a bit, I think it was number 6. Yeah, that was it. Okay, let me do that one. All right, so this problem people wondered about. Okay, it's x plus 6 over y, so it's an evaluating one. We're told to put a 4 in where the x is and a 3 in where the y is. So we're going to go in here and put a 4 where the x is and a 3 where the y is. Now, if you're like me, when you first worked it, you're kind of thinking about fractions because that's what we thought about in class. So what you would have done, what you might have done is this. Thought about that as 4 over 1. Okay, then said, oh, I need a common denominator because I'm adding fractions. Get my blue. So I'm going to multiply by 3 on the top and bottom to get a common denominator. So that first fraction is equivalent to 12 thirds. And then I was already adding 6 thirds. And 12 thirds plus 6 thirds would amount to 18, but they're still thirds, so don't add the denominators. But then 18 divided by 3, you could divide by 3, and you'd get 6 over 1. Don't leave it like that. 6 over 1 is really 6. 6 divided by 1. All right, after I did it, I realized, you know what? Look at this. If I plug the 4 in for x and the 3 in for y, couldn't I have just simplified that fraction? 6 divided by 3 is really 2, and then 4 plus 2 is really 6. So I could have done it that way also. All right, also remember that it's okay to use a calculator. So after you've plugged in that, when you have fractions, I'm allowing you just to use your calculator. You could do that and enter it as a fraction. My calculator would kind of show it like that. Okay, and then it will come back to you as a 6. So remember to be practicing those fraction keys. All right, I want to go back to the homework. I want to do one of the problems near the end. Let's do 18. Let's see if it opened. Nope. Okay, there it is. All right, so let's actually work this problem out. Yours will have different numbers, you know. Okay, so I just had to snip the problem so I could write on it. Okay, here we go. Let me make it a little bigger. All right, so they started off exactly the way I would want to start off. We have the is equal to. The is equal to is the equal sign. Then you've got these two boxes you need to fill in. So on the left side, I have 5 times a number, and it wanted me to use x for the variable. So I'm going to use 5x. Okay. On the right side, it says 8 more than 4 times the number. So there's a lot going on. I like to start just like I did over here, kind of start with the variable and then translate. Start with the x, then back up a little bit and do 4 times that. Then back up a little bit and do 8 more than that. So 8 more than what I have would be 4x plus 8. Okay. So what you do is the first thing you do is you put those in to the blanks on the problem. So 5 times a number, they just want you to type in 5x. 8 more than 4 times a number, that's where 4x plus 8 would go. Then check it. Okay. Now, once you've done that, they come back and say, all right, which of those numbers they gave you would be actually solutions. Okay. So that's when you take your equation that you've written and you start plugging in those numbers. So I'll plug in a 0 and see what I get. Well, that doesn't work. I get a 0 on one side and an 8 on the other. So that's not what I'm going to use. How about a 4? If I plug in a 4, let me erase it so it's not so messy. Okay, I get 5 times 4, which is 20. I get 4 times 4, which is 16 plus 8. That doesn't work. Okay, so 0 doesn't work. 4 doesn't work. Let's try 6. Okay, if I do 6, I get a 30 on one side, but then I get a 24 plus 8, which is 32 on the other. 6 doesn't work. Let's try 8. So you just kind of run through them all. Okay, and I get a 40 on this side, and then 4 times 8 would be 32 plus 8. Oh, that would be 40 as well, and 40 would equal 40. So 8 works. Now this is linear, so I know that's the only one that works, but you may not know that, so you would probably go in and try the 12, and what you'd find out is it does not work, because you'd get 48 plus 8, which is 56 over here, and on this side you'd have a 60. So 8 is the only one that works. All right, so I'm going to stop this video and get it posted.